One of the biggest challenges in game development isn't just the gameplay, it's managing your scenes and data. Loading screens, transitions, persistent data, and making sure your core systems stay alive across different parts of the game. It can get messy really fast. In this video, I will show you a clean scene management setup with a persistent core scene, smooth fade transitions, and a loading screen. A system that keeps your game organized, flexible, and ready to scale. So to better understand the problem, let's quickly look at how scene management usually works in Unity. By default, you load one scene at a time. When you switch to a new scene, the old one is completely unloaded and everything inside it is destroyed. Now, Unity also gives us additive scenes, so you can load multiple scenes at once and stack them together. That's super useful, but on its own, it doesn't really solve the bigger problem. You still need a way to decide what stays loaded, what gets unloaded, and how to handle smooth transitions between them. And that's exactly where my approach comes in. In this video you will learn both how to make a clean scene controller with transitions and how to structure your project and how to set up the scenes themselves. So this is the core idea for the multi-scene architecture. When we start the game, a core scene is loaded. This scene will be persistent and always loaded throughout the whole lifetime of the game. It will hold all the important systems and data that are needed in all parts of the game, like a save system, the audio manager, or the scene controller, which we will build later. This way, we will be able to have those things always available whenever we need them. But this also means that you can, for example, keep music between scenes if you want, and also store data for the next scene. Then we will load other scenes on top of the core scene. Unity allows us to have multiple scenes loaded at once, and we will take advantage of that. And we will not only load 2 scenes at once. On top of the core scene, we can also have another persistent scene that will live while we are in-game and will hold the data of, for example, our roguelike run. In our example, we will build the structure for a simple card roguelike game, but the structure works for all games, and I'm sure that it's easy enough so that you can adapt it for your game easily. Here is what we will build. We will have a main menu from which we can start our roguelike session. Inside the session, we will switch between the match scene and the shop scene. When we end a run, we return to the main menu again. I have prepared a few things for this tutorial. We have the 3 scenes that we will have in our game. The main menu from where we start the game, the match scene, which in a card roguelike would be the card battle screen where we play the match. And we also have a shop scene in which we can buy cards between matches. Of course, all those scenes are only placeholder scenes here and just there to demonstrate the architecture. We won't be able to play a match or buy cards. On all screens I have already prepared buttons that are connected to the scripts. The Start Game button in the main menu will call the Start Session method in the main menu manager. The buttons in the shop will either quit to the main menu and end the session or will switch to the next match. Inside the match we also have a button that quits to the main menu, as well as a button that switches the match scene to the shop scene. To connect this all together, we will need the scene controller, which is the most important piece of this architecture. So let's create it now. We will also need a loading screen and a scene database, which will hold the names of all our scenes so that we don't have to always use strings. The scene controller will be a singleton. This will make sure that we can call it from every script and that we only will have one single instance of the scene controller. We can hide it inside a region so that the code is a bit cleaner. We then also need a reference to our loading overlay. For now, we can just give it 2 methods for the fade in of the overlay and the fade out. Then we will also need a dictionary in which we will hold all our scene slots and the scenes that are loaded in those slots. Like I already said, we will load multiple scenes, but we still want to organize them and only allow to one scene per slot. If we load a new scene into the menu slot, for example, the old scene in this slot will get unloaded. We also have a bool that keeps track if we already are in a scene transition so that we don't do two transitions at once. Then we will need a scene transition plan class inside the scene controller. This will hold all the data for a scene transition. It will hold which scenes to load and which to unload. It will also hold the name of the active scene for the case we want to set a specific scene as the active one. And we will also have the information here if we want to use the loading overlay for the transition and if we want to clean all unused assets when the transition happens. To create the transition plan, we will use a so-called builder pattern with the Fluent API. Don't worry, it's very easy to build. You maybe have already seen something like this somewhere. When we create a transition, we want to chain methods together like this. This way we don't have to write a long complex constructor for the transition plan and can only use those methods that we need. This looks much cleaner and is easier to use. This is also very easy to create. All we need is to have a bunch of methods inside the scene transition plan class that return the scene transition plan object so that we can use it again to call the next method. The load method, for example, will have a return type of scene transition plan and will take a slot key, a scene name, and a bool if we want the scene to be an active scene. We then save all those informations in the transition plan object and return it. We do the same for unload, for overlay, and for the clean unused assets boolean. In the end, we will need a method that will perform the plan. This method will just call a method on the scene controller singleton. We don't have this method yet, but we will implement it soon. Next, we create the only public method that we will need in our scene controller, the new transition method. This will just return a new scene transition plan on which we then can call all our other methods. Then we also create the execute plan method, which we call in our perform method of the scene transition plan. If the system is busy, we return early. Otherwise, we start the change scene routine. Inside the change scene routine, the transition will be performed. Here, we will take our plan and make the transition according to the details of the plan. First, we check if we want the overlay, and in case we want, we fade it in and wait for half a second so that it looks a bit smoother. Next, we unload all slots from the scenes to unload list. We do it with the unload scene routine, which we will implement soon. Then we clean up the unused assets if the plan says so. After this, we can load all scenes from the plan. If we want to load a scene to a slot where already a scene is loaded in, we unload the slot first so that we don't have two scenes in one slot. Last, we fade out the overlay again if overlay is true and set is busy to false. We are almost done with the scene controller. We just need to implement 3 more methods here. The load additive routine will load a scene to a slot. We will use Unity's load scene async method with the additive mode, which will allow us to wait while loading and also to load the scene on top of other scenes. We first only want to load but not activate the scene. The activation of the scene happens in the last 10% of the load. That's why we wait until the progress is at 0.9, so 90%. Then we allow Unity to activate those scenes to set everything up and to call awake and on enable on all objects of a scene. If the scene we are loading should be an active scene, we also set it active here. Last, we set the slot and the dictionary. In the unload scene routine, we check if the scene is loaded. If it is loaded, we unload it and remove the slot from the dictionary. In the cleanup unused assets routine, we clear all assets that are loaded but not used. We shouldn't use this always, but when we have a big scene change or we unload a whole session, we can use this to free up memory. But Unity also does this automatically from time to time and if needed. Oh, and I have a typo here. Next, let's implement the loading overlay. Here we need serialized fields for a canvas group and the fade in and fade out time. Then we will have a fade to method. This method will just fade the canvas group to a value and let us wait for it. We will use this method in both the fade in and the fade out method. We then also will have the scene database. This is not needed, but will help us to keep track of all scenes in our game. Instead of using a string when changing a scene, we can use those constant values. This way we will make sure that we always use the same slots and names. Our scene controller is done now. Let's create our game structure next. For this, let us create two new scenes, the course scene and the sessions scene. The course scene, like I already said, will be loaded in the beginning and will stay persistent throughout the lifetime of our game. It will have no camera. We can delete everything that is in here and create a clean structure and a hierarchy. In the setup, we will place an event system. This is important so that we can use UI events in our game. We will only have this one event system in the course scene and will not have a new one in each new scene. Under the managers, we can place our scene controller. And under UI, we will create our loading overlay. This has to be in the scene so that we can always use it. For this, we create an image and scale it to the size of the screen. Inside, we can place a text. As a parent for our image, we create a new game object and call it Canvas Group. We also give it a Canvas Group component. Make sure that all boxes are unchecked. Initially, we want the alpha to be 0 so that the overlay is invisible. As a parent of the canvas group, we create another object which we call overlay. This will have the overlay script. In the scene controller object, we have to reference the overlay. We then also need a core manager. Inside the start method, we can set up all relevant things for our game before we load a real scene. Here we can load the audio manager and set up the save system, for example. After the setup is done, we can call our first scene transition to the main menu. And here is how it works. Here you can see how easy it is to work with the Fluent API and the builder pattern. First, we create a new transition. Then, we load the menu to the menu slot. We want the transition to be with an overlay as well. As last step, we call perform. Perform has to always be the last step, but the order of everything between new transition and perform doesn't matter. Before we can test it, there is one important step. In the build settings, we have to make sure that all scenes are in the scene list. When we now start the game, from the core scene we can see that the main menu is loaded after a short loading screen. And in the hierarchy, both scenes are loaded. The overlay doesn't look good here, so we just remove it. This looks better. Next, let's set up the session scene. We first delete everything. Here you can place everything that you need for your session. I will create some placeholder objects for a few systems here. You can, for example, have a money manager here. It will be available throughout the session and will hold your money. Because it will always be there, no matter if you are in the shop or in the match, you can always add money to this. The progress manager could hold everything related to your session progress. And the session manager will set the session up. I won't code all this logic here, but you get the point. This data will be available as long as the scene is loaded, and the scene will be loaded as long as you are in a session. In the main menu manager, we can call a transition to the session. Here we load both the session and the session content, so the shop, for example, at once, both under one overlay. Like I already said in the beginning, the start session method will be called by the button in the main menu scene and is already connected. In play mode, you can now see that when we press start game in the main menu, two scenes are loaded, the session scene and the shop scene. We forgot a small thing here. The canvas in the core scene has to be always on top of everything, so let's change the sorting order to something like 9999. We also forgot to set the canvas scalar mode to scale with screen size and set a reference resolution. This way the overlay scales with the screen size. Next, let's implement the functionality of the match and shop buttons. Nothing new here. In the shop manager, the end session button has to load the menu and to unload the session and the session content. Here it also makes sense to clear all unused assets because we are closing large parts of the game and ending the whole session. The switch to match button just loads the match to the session content slot, which will automatically unload the shop from the slot. In the Match Manager we do almost the same. We copy the code for end session from the Shop Manager, and in the switch to shop method, we load the shop into the session slot, which will automatically unload the match. In the main menu manager, we can also remove the clear unused assets in the transition, because I only wanted to show you how to add it, but we actually don't need it here. When we start a session from the main menu, there usually won't be that many loaded assets. And that's it. Now we can go into play mode and start test everything out. We always need to start it from the course scene. The course scene then loads the main menu. We can see that both are loaded in the hierarchy. From the main menu, we can start a session which will unload the main menu and will load both the session scene and the session content. In this case, the shop. From the shop, we can go to the match and back again. This will only change the content, but not the session scene. The To Main Menu button will now close the session and open the main menu. Everything works as expected. Perfect. Now you have an idea how to structure your project. The scene controller and structure can be used for all projects. I hope you found this video helpful. If you want to support me, please leave a like and a sub. It helps me a lot. Thank you for watching and see you next time.